Okay, you're going to need to take out your Beyond the Bell quadratics review assignment. If you don't have this page, you can copy down the ideas that we're doing on a separate sheet of paper. We're going to review the first and back page, and as a reminder, you guys have this test on Friday, so please make sure you study it, and please make sure you come in for at least one lunchtime. Now obviously you can't come in today, but you could come in Wednesday or Thursday. So you have 2 more days to come in at lunchtime to earn the right to take the Beyond the Bell retake on Friday for these 2 pages. Okay, I'm going to go over question number 1. The first thing I notice is that they've given us 2 points right here, but that those roots are not exact. The only exact point they've given me is the vertex. And the vertex, that pen is too big, the vertex is 1, -2. I also noticed that this is an upwards facing parabola, so that means that A is +1. Now we know that vertex form is y equals a times x minus h squared plus k. Now when we work with circles, we know that when h and k go into the equation, they're the opposite. But this is a parabola, so parabolas are different. When the h goes in, it's opposite, but when the k goes in, it's the same. So opposite and same. And then the a value will go here. So that means that I'm going to get y equals +1 times x, well, opposite of x is -1 squared, same k value, -2. Now, getting here is part of the journey. This is the vertex form, but they asked us to write it in standard form. So the first thing we need to do is evaluate x minus 1 squared, which I'll do right here. So x minus 1 squared is the same as x minus 1 times x minus 1. Now if you FOIL that out, you would get x squared minus 1x minus 1x plus 1, or x squared minus 2x plus 1. This right here is going to replace what we have here as x minus 1 squared. So I get y equals +1 times this new quantity minus 2. And that's x squared minus 2x plus 1. The next thing we're going to take care of is we're going to distribute the +1. So that +1 is going to distribute to all 3 terms. And it turns out when you multiply by a 1, nothing changes. So I get y equals x squared minus 2x plus 1 minus 2. The last thing we'll do is combine these like terms and get y equals x squared minus 2x minus 1. That's the equation of this parabola in standard form. And we know that because we can see A, B, and C. Okay, it looks like now we're ready to take a look at our second problem. It asks us to sketch the graph of f of x equals x minus 3 times x plus 1. This function is in factored form. And factored form means that just by looking at it, I can see the roots. Now in order to graph a parabola, you really only need 3 points. Those 3 points are the 2 roots and then the vertex. And we're lucky this is in factored form. Since it's in factored form, I look at this, I see a number, I see -3, and the opposite will be my root. So I see -3, so +3, comma 0, that's a 3, 0, that's a 3, 0, was one of my roots. And then my other root that I see is this is +1, so that means -1, 0. So I have one root at -1, 0, and I have another root at 3, 0. Now once you've graphed your 2 roots, it's really easy to find the vertex. The vertex is right in between the middle. Because I drew, let me move this better, -1, there you go. That looks like the middle of these 2 points is right here at x equals 1. That means somewhere on this line the vertex lies, and it could be up here making it a frown or down here making it a smile. That means that at 1 comma something, we'll find our vertex. So the question is, what does y equal when x equals 1? What we're going to do is we're going to substitute 1 into this equation right here. So I get it's x minus 3 and x plus 1. So I'll replace my 1 in there, and I end up getting, now this is where you could put this entire part, you could put this whole thing in the calculator right now. So you do parentheses 1 minus 3, parentheses, parentheses, 1 plus 1, parentheses, enter, and get a value. Or you could do the order of operations and get negative 2 times 2, which is negative 4. So that means that this value is negative 4. So that at 1, 1, negative 1, negative 2, negative 3, negative 4 is our third point. Now, once you have those 3 points, you can make a beautiful parabola. And that's how you do number 2. Alright, now we're ready for question 3. For question 3, they ask, use the graph to find the following requested information. Find the x-intercepts, write the function in factored form, write the function in standard form, and write the y-intercept. Okay, so the first thing I need to do is take a look at my graph and find the x-intercepts, or the roots. Where does this blue line cross the x-axis? It crosses at x equals 1 and at x equals 3. So that's these 2 points right here. It's kind of hard for me to draw this, and I'm not going to do it. Okay, now my next step is to write this in factored form. Now to write this in factored form, I really want you to recall what we just did up here. This function was in factored form, and we took the roots out. And when we found the roots, they were the opposite of what we saw. Now we're going to do the reverse. I know what the roots are. Oh, sorry. I know what the roots are, but what are they in factored form? So I have y equals, okay, one of the roots is positive 1, so that means in the function it'll be negative 1. And then I have a positive 3, so it'll be a negative 3. Now there's one feature that we're missing here, and that is the fact that this function right here is downward facing. That means that the a value, is negative 1. So we have to put a negative 1 right here to reflect that it will be a downward facing parabola. Now our next step is to put this in standard form, which means we'll have to FOIL it out. So the first thing I'm going to take care of is this piece right here. I'm going to do the negative 1 at the end. So my question is, what is x minus 1 times x minus 3? That'll be x squared minus 3x minus 1x plus 3, or x squared minus 4x plus 3. So that means I have y equals negative 1 times x squared minus 4x plus 3. And when I distribute that out, that negative 1 will change all the signs inside the parentheses. Every number stays the same, but they change values. The last thing we're going to do is find the y-intercept, and I'm going to remind you that the y-intercept of a function is always 0, comma c. So if you know how to find your a, b, and c from standard form, you'll be fine. So a is negative 1, b is 4, and c is negative 3. So that means that our y-intercept is 0, negative 3. And that's how you do question 3. Now when you turn your paper over, you'll see question 4, 5, and 6. These 3 questions we'll be going over next class, but I'm showing them to you today because your job tonight is to make sure you do questions 4, 5, and 6, and that you review questions 1, 2, and 3. Remember, you must come to lunch tutoring on Wednesday or Thursday at least once, so pick one day, and you need to work on these 2 pages to review for the exam that you'll have on Friday. So let's get started today. I'd like you to turn to page 7. I'll give you a moment to do that. And we're going to do what I call summary notes. My S isn't turning out so good. That's an S. Summary Summary notes. Summary notes means these are things that you already know, and we're just kind of pulling it all together. So I assume that now you're on page 7, and we're going to start by writing the equation of a circle. So the equation of a circle is x minus h squared plus y minus k squared, which equals the radius squared. And we're going to identify that hk is the center, and that r is the radius. I'm sorry guys, the pen's not working very well. And last, that xy, this is the part you need to remember today. So hk is the center, r is the radius, and hy is a point on the edge of the circle. Circle. Okay, so that means that we could label this center point as hk. We could label this as our radius, and we could say that this point right here is the point xy, a point on the circle. So xy represents every single point on the edge of the circle. The blue line is the radius, and hk is the center of the circle. Now if you need to, you can pause the video, but I'm going to go ahead and keep on moving on. Now since these are summary notes, we're not going to do every example. We're only going to highlight a few important ones. So the first one I'd like to take a look at is this example right here. So it says find the radius of the circle. I'm going to say I want to know what the radius is, and I want to know what the center of the circle is. I'm going to give you guys a few seconds. I'll pause the video. Go ahead and see if you can figure out what the radius is and what hk is. Okay, I hope you pause the video. And now that you're ready, let's check it out. Okay, so the radius is not 16. The radius is 4. So as a reminder, you need to square root, that says square root, guys, sorry. You need to square root the radius if it's coming out of the equation. So in this case, the radius would be 4, and hk is 0, 0. So I wanted to point out to you guys that this equation could have been written as x minus 0 squared plus y minus 0 squared equals 16. And this equation right here is equivalent to this one. So I just wanted to point out that both are okay for me, and if you had written this one on the right on your test, it would be the same as if you had written this one. Okay? All right, how about we turn the page to the next one. Okay, we're skipping page 8, so go ahead and flip your packet over to page 9. And I have another challenge for you. So we're on page 9, and I'd like you to take a look at this example right here. So I'm going to trail you. We're going to pause the video, and I'd like you to look at this equation, write the center, the radius, and then I'd like you to graph your circle. Go ahead and pause the video, and then unpause it when you're ready to see if you got it right. Okay, so you had a moment to go ahead and do this problem. The center is 3, -2, and the radius is 4. So if you went over 3 and down 2, you'd have a center point right there. And then the radius is 4 in all directions. So I'm going to go 4 south, 1, 2, 3, 4. Plot a point, 4 to the right, 1, 2, 3, 4. 1, 2, 3, 4 up. Let's see if I can get this one to go there. Kind of. And then 1, 2, 3, 4 to the left. Your last step is to connect these into a nice circle. Okay, I did a terrible job. I'm sure yours looks better than mine. So this is a circle at the center point 3, -2 with a radius of 4. Okay, this is a simple example. Let's kick it up a notch. So now I'd like you to try out this problem right here. So again, we're going to pause the video. I'd like you to look at this equation, find the center, find the radius, and then graph it. Okay, good luck. Okay, so the center of this circle is 3, 3, and the radius of this circle is the square root of 8. Oh, that's terrible. Let's see if I can do that again. It's the square root of 8. A little bit better. Okay, if you wrote the square root of 8, that's right. But there's more to write here, because the square root of 8 is actually the square root of 2 times 2 times 2. Now you guys know how this works. For every pair, 1 comes out. So there's one pair. So that means a 2 will come out. So the radius is actually 2 square root 2. And that's actually what you have to write down as the radius. So you have to simplify the radius. Now, I know the center, I know the radius, so I'm ready to graph. So the center of my circle is at 3, 3. So there's my center right there. Now my radius is 2 square root 2, or the square root of 8, right? Now the square root of 8, or 2 square root 2, is about 2.8. So that's its estimate. So I'm going to use that to make my graph. 2 and a little bit. So 2 and a little bit, 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 and then I'm going to connect those into a circle. Not so bad that time. Okay, we have 2 more examples to do. Let's go ahead and turn the page. So here we are on page 10, and you know what, I lied to you. We actually only have one problem to do. The problem that we're going to do today is this one right here, where it says, write the equation of a circle with a radius of 2, -3, and a radius of 12. So that means that HK is represented here, and our radius is right here. So I'm going to be putting those into the equation that we all know, x minus h squared plus y minus k squared equals the radius squared. Remember the rule, when the hk goes into the equation, they change signs. So I'll have x minus 2 squared plus y plus 3, not k, 3 squared equals the radius squared. Now the radius is the square root of 12, so it's the square root of 12 squared. Now everything's ready to go except you need to evaluate this. You can evaluate it in your mind and do the mental math, or you can do it using your calculator. And when you do, you'll get the answer, which is the square root of 12 squared is 12. So the equation of this circle is x minus 2 squared plus y plus 3 squared equals 12. Okay, we're going to use all of these summary notes today in our stations. Let me go ahead and go over those directions with you now. So today we're going to be doing our stations in the middle of class, because at the end of class we have a little bit of work we're going to do. So we're going to continue with our notes at the end. So consider these stations as being review or important prerequisites for what we'll be doing next class. So let's start off with what's on the left of the classroom. So everybody go ahead and turn around and look to the left of the front of the board. Over there you should see something, a station that talks about the 5-minute time challenge. This is on page 13, and the idea is that you're going to try to do those four problems in 5 minutes or less. Now if it takes you more than 5 minutes, that's fine, but 5 minutes is the goal. Now I would like you to write at the top of your paper your start time and your end time. This is an individual station, so obviously you do this part alone. You can sit next to a partner, but you're not working with them. Your goal is to finish it in 5 minutes or less by yourself. And don't forget to write down the start and end time. The next station is behind that one. It's in the back left corner. That station's called Convince Me. This one's on page 19. I didn't write that here. It's page 19. Let me double check and make sure it is page 19. I'm right. Okay, so page 19. You're going to go ahead and rip page 19 out of your packet, and your job is to convince me that these 3 points that are given on this paper, that those 3 points are on the edge of the circle. They may all be on the circle, maybe 2 of them are on the circle, maybe only one's on the circle, but I want to know, how do you know? Your job is to show me using math and words how you know. Once you've finished, make sure you write your name and the period, and you'll be turning that in before the end of the stations. There's some hints there as well. The last station is in the back right corner by our kind of work table. There's a piece of poster paper there that says standard form to expanded form. Everybody see it? I hope so. Now over there, the example for number 1 is there. This is on page 17. Page 17. What you'll be doing is you're going to be doing algebra. So you're going to take an equation that's in standard form of a circle, and you're going to be turning into what we call expanded form. I recommend you do example 1, or you copy the example 1 that I have, and then I want you to notice that to the right of that board is an answer key. It's possible most students in my previous class finished, but some didn't. So if you do not finish in the time available, this will probably end up being your homework. Now you have 15 minutes per station, which is kind of too much because obviously you're only going to be using 5 minutes here. So you're going to have 45 minutes total to complete all 3 stations. Remember, page 19 must be turned in, and what you don't finish, anything you don't finish, aside from number 2, is going to become your homework. All right, good luck. All right, I hope you were able to finish all of your station notes and station activities, and now I'd like you to turn to page 21 for a quick review on completing the square. Now, completing the square is what we learned last chapter, and it's something that will be a key component of what we are going to be doing next class. So I want to make sure we review it. So let's go ahead and start by turning to page 21, and let's write out some steps. So I tried to write out the steps, and my pen's just not working well. So it's just easier if I just kind of took a picture of the notes and then we go over them. So what I'd like you to do right now is to copy down these steps on the right-hand side of how to complete the square. And then I'll annotate these as you're going through them. So the first thing you're going to do is find A, B, and C. Okay, and when you find A, B, and C of your function, you want to make sure that first that A equals 1 and that x squared plus bx equals c. So basically what you're checking is c on the right hand side of the equation. The second thing you're going to do is the completing the square part. So this is something we do in our mind. So it's not something that we are doing in the equation. We're taking that b value, we're cutting it in half, and then we're squaring it. So in your mind, find b, cut it in half, and then square it. The third thing we'd like you to do, once you find that value, and I know I'm going a little fast, but I promise I'll leave this up for you, is I'd like you to take the value that you just found and you're going to add it to both sides. So take the value you found and add it to both sides. Once you've done that, you'll have a new kind of 3-term trinomial on the left, and that one you're going to factor. And on the right, you'll have some numbers that you need to add together. So you need to simplify the right. So factor the left and simplify the right. Once you've done that, you square root the left side and the right side. And once you square root those two sides, just as a reminder, don't forget that plus or minus. The last thing you do is solve for x. So you get the x alone. I'd like you to, we'll pause the video and give you enough time to copy down these notes, and then we're going to do example 1 together. Okay, let's go ahead and scroll down, and I think what I'm going to do is I'm going to move this guy Let's see if I can move these notes down here. Yeah, I can. Okay, I'm going to move these over here as we do these. Okay. All right, let's see. Okay, so I'm going to start, let me move this down just a little bit more. Let's follow our steps, step by step. So we're going to find A, B, and C. So let's see. A is 1, B is -4, and C is 4. Now this equals 3 does not, we're not going to consider. It's on the right hand of the equation, so we're not going to bother with it. So the first thing I check is A equal to 1? And the answer is yes. So that's a good thing. The second thing we need to check is C on the right? And the 4, this 4 is not on the right. So we're going to have to do some math to move it over. So let's go ahead and copy this down again. So we have x squared minus 4x plus 4 equals 3. So I'm going to go ahead and subtract 4 from both sides. And when I do that, I'll get x squared minus 4x equals -1. So I've gone ahead and I've moved the C over. Okay, we're ready for our step 2. It says, in your mind, find B, cut it in half, and then square it. So here I am in my mind. This is my mind. B is -4, and I'm going to cut it in half. And when I do that, I get -2. Then it says then square it. So I'm going to take -2 and I'll square it, and I get +4. Okay, it says now add that value to both sides. So I found B, I cut it in half and I squared it, and I got the number 4. In our notes it says add that number to both sides. So we're going to add 4 to both sides. Now remember I said something about having a new trinomial on the left? This is that new trinomial. So this trinomial on the left is the one I'm going to factor, and this on the right is what I'm going to simplify. Factor the left, simplify the right. Okay, so let's see what that looks like when we factor the left. So I have the question, what multiplies to 4 and adds to -4? What multiplies to 4 and adds to -4? That's -2 and -2. So I get x minus 2 times x minus 2. Okay, so I factored the left. Now simplify the right, equals 3. Now, a nice way to write this is x minus 2 squared equals 3. And now we're ready for step 5. Square root both sides. Don't you forget that plus or minus. So they're squaring, so I square root. Now remember, when you square root, only 1 comes out, so I get x minus 2 equals plus or minus. Now if you put the square root of 3 in your calculator, you'd get a decimal. So remember, if that happens, we leave the square root of 3 alone. Now we're ready for our last value, our last step. We need to solve for x. So to get x alone, I'm going to add 2 to both sides. My 2's not working very well. And when I do, we get x equals 2 plus or minus the square root of 3. Remember, that means we have 2 roots here. So one of the roots is 2 plus square root 3, 0. That's one of my points. And the other one is 2 minus square root 3, 0. I think instead of or, we should say and, huh? And those are our 2 roots. Okay, guys, if there's any class time remaining, which I think there is, your job is to spend the rest of the time studying for your quadratics review. Now, on the desk that you usually get your materials on at the front of the classroom, there should be a stack of packets that say Quadratics Beyond the Bell. I'd like each of you guys to grab one of those packets, and your job is to choose some problems and do them. Okay? Another option that you could have is to do the back side of your quadratics review. Basically, I want you to use this time to study. Use it. Have a great day, and I'll see you guys tomorrow. Bye.